Hey guys, welcome back to Learning Kotlin Live, and this is the episode 52 of it. Um, in even episodes, we talk about we read Kotlin documentation. So, basically, let's see. Currently, we're halfway, maybe not halfway, we're just starting to learn that the idea behind coroutine, which is one of the most well-known difference between Java and Kotlin. And so, um, before I get everything clear, I'm going to review what coroutine is in each episode. So let's take like 2 minutes to have a brief understanding reviewing what coroutine is. So coroutine is a lightweight thread. That's the basic idea, which doesn't create a real thread that is binded to computer architecture resources. And so you create coroutines with these coroutine scopes and launch something in it, just like Java runnables. And so they are let's see. Okay, I'm totally missed out. It's been a while since I last take a look at these coroutine thing. Oh, this is nonsense. Don't need to care about that at this moment. Waiting for a job. So it is just like thread and can be joined. This is the idea of this block. And structured concurrency. Oh, here it is talking about if you run run blocking and a launch and print some hello. Let's see what happened now. So you get that hello world, and so this hello is first run, and that launch is waits until print launch returns. So there's a concept called coroutine builders, and run blocking itself is one of the builders. And there is a hierarchy or some, let's say, hierarchy itself actually explain it is pretty it actually already explains it. Um, so this run blocking waits until the every subcoroutine in it to finish. So that's why this print loan hello this is why this launch delayed for which delayed for a second, and after print loan hello actually everything exited, and but because the subcoroutine is still blocking, or it's still not completed yet, so so the subcoroutine is still executed thoroughly, fully. And again, there are some other coroutine scope builder. Wait a minute. There are coroutine builder and coroutine scope builder. Um, and there are coroutine builders, and coroutine scope is one of those builders. And the main difference between run blocking and coroutine scope would be the latter does not block. So here we have the coroutine scope, and because it does not block, so this items that will be executed here would probably be coroutine scope is over, then the task from run blocking, and oh, this, and this. Let's see if I'm correct. Because this one is non-blocking, so oh wait. So that's why this one can come first. Task from wait. Task from coroutine scope. Here's the first one. It still waits, but it's not blocking. What does that mean? So it's actually this one, then this one. Wow, that's not something I'm expecting. Wait a moment. Oh, I think it is blocking because this is dispatched to this run blocking. So here it creates a new coroutine scope and coroutine launch inside of it would not block this one, but because this whole block is in the run blocking, so this whole thing is blocked. So that's why we're going to have this will be launched and it's non-blocking. I mean, the thing in it is non-blocking because there's a launch, but coroutine scope itself is okay. I'm tired of this. Let's see. Is anyone watching this live? I need to take a look at the the chat. Nope. Don't see anyone in the chat. So wait a minute. So let me know if you feel like there's anything that is unclear. I'm kinda lost here as well, but I think I talked about this in episode 50 or maybe 48. So you can review the whole understanding of this block, but anyway, I don't feel like this is something that we really need to know now. So the only idea behind this is there are different scope builders, and some are blocking and some are non-blocking. This is something we're going to talk about very soon, so no, I'm not going to cover this one. And this is just yet another demonstration of how lightweight a coroutine is. You can't repeat something for, you can repeat launching the coroutine for 100,000 of times, but it's still working. While if you're doing this with Java thread, you probably get an out of memory error. And global coroutines are like daemon threads. Wow, this is just talking about if we are doing something in the main function or whatever, if we are doing some computation in a global scope coroutine, it is not going to leak the whole class or whatever the runtime is, because let's take a look at this. You will see that this is only called 3 times, and that's because after this delay, this global scope will be interrupted. I tend to say it that way, but maybe that's not the true, but it's kind of like interrupted, and it's not going to leak whatever resources it's not going to hold on to the resources. So this is what we're going to talk about today: composing suspending functions. Sequential by default. Assume that we have two suspending functions defined elsewhere that do something useful, like some kind of remote service call or computation. We just pretend they are useful, but actually each one just delays for a second for the purpose of this example, of course. So if we're doing something, whatever, what do we do if need to invoke them sequentially? What? Is this grammarly correct? First do something useful one and then do something useful two and compute the sum of their results. In practice, we do this if we use the result of the first function to make a decision on whether we need to invoke the second one or to decide on how to invoke it. We use a normal sequential. Well, yep. So this is another suspending function. Maybe not. I thought that only suspending functions can call suspending functions. Isn't that true? Function main run blocking. Oh, so that's why. With that run blocking, we can do something that is, we can call some suspend function. But anyway, oh, this is not a, yeah, this is actually not a function. Okay, so that's why. So you measure time in milliseconds. What's this? Ah, what's this? It's a function execute a given block and return elapsed time. Oh, okay, this is handy. So basically, you get the elapsed time and print it. That's all. And what's this? It's a function. Okay, so probably maybe this one is inherently a suspend function. I don't know. I don't know if this takes a any function that takes a function actually takes a suspend function. I'm not pretty sure yet now at this moment. But so what it would like to illustrate is you can call coroutines just like not normal functions. The answer is 42, but I don't think it this is not actually demonstrating anything to me, because we still don't know if these two functions are run sequentially, I would say, but at least we know that both functions returned before they are printing, or else this will not be 42. Concurrent using async. What if there are no dependencies between invocation of do something useful 1 and do something useful 2, and we want to get the answer faster by doing both concurrently? Well, this is where async comes in. And if we wrap the suspend functions with an async, we can do something like, oh, there's a way. I see. So basically, you call this, and these two returns directly, and then this line is executed. And when this line is executed, it will wait for these two to return. And once that these two both returns, you get 1 and you get 2. Or the result of 1 and 2. This looks just perfectly like Java futures. So yep, you can see that the elapsed time is shorter, a lot shorter, because we all know that these two functions actually delayed for 1 millisecond, 1,000 milliseconds actually. So that's why if they are run concurrently, we get a a time which is slightly larger than 2000 milliseconds, but for this case, what is printed? Nothing's printed. We can see that the time elapsed is roughly slightly more than 1000 milliseconds. Well, it looks like there's some bug here. Yep, there's a bug in here. Let's try to get to the Kotlin playground. There it is. And let's do it this way. I think it's compiling anyway. But nothing is returned. Why? Huh? What if we don't print anything? I guess nothing is going to be printed. Oh, okay, there actually it's going to be something that is super short. That's my guess. Huh. Nothing is printed. So it's there must be something to do with these two async. Oh wait, this is not working. Well, for some unknown reason, it seems to not work now, but I hope you go get the idea that it is just telling us that it should be working, or at least, oh, it's working now. I don't know why, but it's finally working. So let's take a look at, yeah, it's slightly more than 1 second with some slight overhead, and that's the idea. Yeah, we get it now, finally. Lazily started async. Concurrency with coroutine is always explicit, which means that if you don't add async, it is going to be blocking. So there is also some laziness. Oh no, I don't think I can finish these. Start parameter. You can pass in this start parameter and the and the lambda later. With coroutine start.lazy, it start coroutine only when its result is needed by some await. Well, that actually basically means that for normal async, when this line is executed, it is started. But with the start equals to coroutine start.lazy, it's not started before this. So if we have some, like, say, wait, delay, if we get a slight delay here, if we have a slight delay here, the total time needed would be like 29. But if we don't provide that coroutine start.lazy, I think this is still going to be like 1, slightly larger than 1. Yep, that's the idea here. So look here, 2 coroutines are defined but not executed as in the previous example. Note that if we have caught await and blah 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 blah. Async style functions. We can define async style functions that invoke do something useful one. Oh, okay, so this is kind of just like a wrapper to it, I guess. Async itself is a coroutine builder, so it's a builder rather than a keyword, and we can build it with an explicit global scope reference. Well, I'm just wanting to take a look at it. What's the idea behind these channels? Are they scope? Nope. I hope not. I hope not, because I just skipped it. And I kind of feel like it's a little bit hard here. Anyway. The result type of something useful one async is deferred integer. Makes sense, just like future. Note that these blah 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 async functions are not suspending functions. They can be used from anywhere. Yeah, of course. Yep. However, their use always implies asynchronous execution of their action with the invoking code. So this is the function main, and these things are thus outside of the yeah, the idea is we don't have run blocking, which usually happens in these kind of examples. We wrap it with run blockings, which makes it which wraps the suspend function to a normal function, but leaves async style functions are inherently normal functions, which are not suspend functions, so we don't need that run blocking wrapper. So we call something useful one async, something useful two async. And because these two items are suspend functions, they can be initiated outside, but to use them, we still need this await. And with this await, this statement becomes part of a suspend function, so we need run blocking to wrap it. Well, so the basic idea is still this is async, this is asynchronous, and this is asynchronous, and we run another, and we wrap these two coroutines with a run blocking, and so the result is something like 1200 milliseconds. Oh, and here's a notice. Using this style, this async and await style in Kotlin coroutines is strongly discouraged, and here's why. Consider what happened if between value 1, this line, and this line. So with Kotlin, there is the idea of structured concurrency, which we just reviewed, which is the hierarchy of coroutines and the subcoroutines. Um, the in other languages, you might have some problem that, well, let's say that some exception is thrown here. Then something useful one async is still running because it is on another thread. But this is, well, because of this um, exception, it's actually something we need to stop. So that's why here Kotlin discourage us to use this pattern to write code. So here's the follow up of structured concurrency, which was just um, illustrated, mentioned. So the async computer is defined as extension of in the scope, and that is with what coroutine function provides. So the encouraged way to do with this is you write a suspend function, which do the concurrent, which is named concurrent sum. So you do everything in another coroutine scope, and you await in that coroutine scope as well. So if something goes wrong inside this concurrent sum, like say an exception is thrown here, all the coroutine that were launched in its scope are cancelled. These do something useful 1 and do something useful 2 will be cancelled. I need the original code. The answer is concurrent sum, and we need the exception. Let's see. So first of all, without that exception, everything completes in roughly 1 second. But if there's an exception here, wow. What? Third type is any? What? Oh. I don't think it's wise to do something in the what? What else could this mean if it is not returned? Anyway. Wait. This is weird. It is still called. It is still called. Useful 1, useful 2. Even. So they are not suspended. Oh, because this. This. I don't know. It should be suspended, right? 1 dot wait. Oh, because it is catched. So this one is continued. So no, we probably don't need this catch here. Or at least we catch it. I don't know. I want to skip this line, but I don't want to catch everything. How about this? Oh, I need that catch. I don't need this line. Is this correct? I don't quite think so. Yeah, this is still not something that I'm expecting. Yeah, they still ends. How do I demo that? Oh, maybe. How about let's try catch outside maybe. Where is this code? Yeah, it's completed in the do something useful 1 and do something useful 2 are not called anymore. And if there is no runtime exception, they will complete. And if something bad happened in between, the whole coroutine itself, although launched already, when this coroutine scope exists because of some exception, these two are cancelled as well. That's the idea behind this. And probably that's it. Hopefully that's it. And yeah, that's the other idea of this. And cancellation is always propagated through coroutines hierarchy. Well, this is a little bit complicated. Second child throws an exception. Where is it? So there's a failed concurrent sum, which there is going to be some arithmetic exception. Second child, where's the second? Oh, here's this async. Second async. This async wrapper makes it a suspend function, and yes, this is the second. This is a child coroutine of this coroutine scope. This is child 1 and this is child 2. So second child throws an exception and first child was cancelled, and the computation of and this exception is finally catched. So I think the idea behind this is basically your siblings are cancelled and then the parent is cancelled. And that's all for today. Let's see if anyone is in the chat. Nope. I think that's going to be everything I want to cover today then. Are we still online? Yep, we're still online. Yeah, so that's all for today. Hope you enjoyed it. Let me know if you have any questions. Bye bye.